It is known that if a car travels in a uniform velocity, let's say uniform velocity u is equal to 1 meters per second, then its distance traversed in each and every segment of its time is equal to each other. What I mean to say is that its distance traversed from t0 to t1 is equal to its distance traversed from t1 to t2, which means that distance traversed from t0 to t1 is s1, and its distance traversed from t1 to t2 is s2, which means in simplified terms that s1 is equal to s2, and this implies if and only if the car is traveling in a uniform velocity, and in this case it is 1 meters per second. Now, what can be the case if the car is not in uniform velocity? Well, in this case, we consider the car is moving in a uniform acceleration. Well, just for consideration and for convenience, we say that the car is traveling with a uniform acceleration of 1 meters per second squared. Now, we have to calculate its traversed distance in a particular period of time, let's say the second. We are here to calculate the distance traversed by the car in the second of its journey. Now, how do we calculate that? Well, the distance traversed by the car in the second of its journey, according to the figure, is basically s2. And from the figure, we can say that in the entire 2 seconds of its journey, the car has traveled a distance of s, which is this. So we can say that s is equal to s1 plus s2. Now, we are here to calculate s2. Just doing some simple algebra, we can say that s2 is equal to s minus s1. We have all the variables in calculating s as well as s1, since we know in this case acceleration of the car, which is uniform, is 1 meters per second squared. We know the value of t0 and t1 if necessary required, and we also have the initial velocity of the car, which is 1 meters per second. So we can say that s is equal to u times t2, because we are calculating, of course, the distance traversed by the car in 2 seconds. So s is equal to u t2 plus half times a times t2 squared. And of course, s1 is equal to u times t1, since the car is traversing through a period of 1 second. ut1 plus half times a times t1 squared, right? And just plugging in the values, we can get the expression that denotes or describes the distance traversed by the car in s2, or the second. Now, if we plug in the values, of course, we get that u is 1, t2 is of course 2, plus half times acceleration stands as 1 meters per second squared, and t2 is of course 2, and squared off, and you get that it is 4 meters. Alright, so we have s is equal to 4 meters. And the same goes for s1. We get that u is 1, t1 is 1, half times a is 1, and t1 is 1. And if you square it off, you get the squared over here. Plug in the values in a calculator and we get 1.5 meters. So we have that s is equal to 4 meters and s1 is 1.5 meters. So from this expression, from this expression, we get that S2 is 4 minus 1.5 meters, which is basically 2.5 meters. So this is how you calculate the distance traversed by the car in the required tth second. Now we want to find out a general expression that describes this entire motion in simpler words without going through this entire thing that we have done. We want to find a general expression for the distance traversed by the car in the tth second. So how do we do that? Now, if we'll go and look back at our original case, which is here, we can say that the entire displacement S is equal to the displacement made in the first second plus displacement made in the second. All right. So we can of course say that if we are here to calculate the displacement made in the tth time or the tth second, and the total displacement made is displacement total, and the displacement made right before the second that we are calculating is t1 minus tth second, which is displacement made in the t minus 1th second, then we can say that S total is equal to S tth plus S t minus 1th. Or we can just write as S tth is equal to S total minus S t minus 1th. All right. Now, we can also derive from this the general expression for S tth, because we know the variables that we need in order to derive this equation. Let's say that the car is in uniform acceleration of a, and its initial velocity is u. And now we can derive the equation, the general equation for S tth. So S total is of course u times t2. Let's go back to this equation. Here t2 is 2 seconds, but of course we don't put in t2 over here. We say that it is u times t, because the entire time is t, where we want to calculate the total displacement made, plus half times a times t squared minus u. Here's the catch. For S t minus 1th, the time that we are going to take into consideration is of course t minus 1. Just like we did in this case. For calculating S t minus 1th, which is S1, we took into consideration t1, which is 1 second, and not 2 seconds. We took into consideration t is equal to 1, which is 1 less than t2. The case is similar over here as well. So we say that u times t minus 1 plus half times a times t minus 1 whole squared. All right. Now you generalize this entire expression to some simple algebra. All right, so you get ut plus half times a times t squared, and inside the bracket you get ut minus u plus half times a times, here comes the algebra, the formula a minus b whole squared. So you get the t squared minus 2t plus 1. You generalize this again, you get ut plus half times at squared minus ut, minus and minus before u becomes plus u minus half times a, and times the expression inside the bracket. Alright, so as you can see over here, the ut's cancels themselves off. So you're left with u, and if you put in half over here as a common expression, you get half, and of course you have a as common as well, so you get half times a, times t squared minus the expression inside. You further simplify this thing and you get half a t squared minus t squared plus 2t minus 1, since you have a minus over here. And you do some further simplification again, and you get that u plus half a, the t squares cancels themselves off, and you get 2t minus 1. Therefore, s tth is equal to u plus half a 2t minus 1. This is our generalized equation. But how do we verify this? Well, you simply put this formula into this very case that we have over here. In this case, our required t is equal to 2, because we are here to calculate the distance traversed by the car, the displacement made by the car in the second. Acceleration is, of course, 1 meters per second squared over here, and the initial velocity was u is equal to 1 meters per second. So we plug in the equations over here. Well, again, a is equal to 1 meters per second squared, u is equal to 1 meters, and t is equal to 2. You plug in the values over here. So s tth is equal to 1 plus half times 1 times 2 times 2 minus 1. And now, this generalized equation will stand by its expression if and only if the resultant value, after plugging in the numbers over here, corresponds to our answer over here, which is 2.5 meters. So let's see. 1 plus half times 4 minus 1, which is 1 plus half times 3, which is 1 plus 1.5, which is 2.5 meters. So here you go. The distance traversed by a certain object in uniform acceleration in a particular period of time. That's all.